I'm Scott Brown, Executive Director of Device Development at Merck. My academic background is in both science and engineering. My two co-inventors are Peter Basile and Michael Galluppi, both mechanical engineers. We started development with a core team of engineers and scientists and expanded the team as we moved forward. All told, there were about 15 people involved in the development. The therapeutic objective of all inhalers is to get the right amount of medication directly to the diseased part of the lungs, while minimizing the amount of medication that can wind up in the upper airway, gut, or deep lung. These are topical drugs that are meant to be applied directly to the target organ. Getting the right amount of drug on target while minimizing off-target delivery has always been a challenge. Off-target delivery has little or no therapeutic benefit, and it can increase the potential for unwanted side effects. On-target delivery to the lungs requires that the drug particles are sized within a very specific range. Particles too large can wind up in the upper airway. Particles too small can get into the deep lung and result in undesired systemic delivery. The polyflux collider patent covers a new inhaler design that optimizes the drug particle sizes for direct delivery to the diseased part of the lungs while minimizing off-target delivery. Powder inhalers utilize the patient's inhalation energy to move the powder from the inhaler into the patient's lungs. The energy is also used to break the powder into fine particles. In dry powder inhalers, drug particles are often combined with lactose particles to promote easy flow for metering the powder. These multi-phase particles are called agglomerates. We started investigating ways in which we could better use the kinetic energy of the flowing powder to break the agglomerates into appropriately sized particles. For the drug to be effective, the agglomerates must be broken down in size so that they can be carried to the diseased part of the lungs. The flow path within the dry powder inhaler is designed to de-agglomerate the drug lactose particle. Optimizing this de-agglomeration was the key to success. We learned through experimentation and published literature that increasing the number of particle collisions within the inhaler would improve de-agglomeration. We accomplished this by separating the powder into separate reservoirs in the inhaler where two separate streams of powder would result from the patient's inspiratory flow. We call our inhaler the polyflux collider. The polyflux portion of the name refers to the two individual streams of entrained agglomerates. The collider portion is the unique aspect of the patent, the forcing of the two flow streams into the face of each other. The theory being pursued was that we could get extreme particle-to-particle collisions, which further de-agglomerate the particles. Additionally, we theorized that some of the collisions would rebound into the oncoming flow stream to create new collisions and receive a second and perhaps third chance at de-agglomeration. So the polyflux collider effectively takes the available kinetic energy of the flowing particles and maximizes de-agglomeration. It's important to note that the formulation plays a big role in the successful drug delivery to the lungs, and Merck's respiratory formulation scientists worked in parallel very hard to optimize the formulation to work with the inhaler. The optimized device and formulation yielded the winning combination. We knew we had a winner when we saw close to 2 times the amount of appropriately sized particles without increasing the amount of powder per dose. In the words of my colleague Peter Basile, Edison brought light to the darkness and song to the silence. It feels wonderful to carry the tradition of invention forward and to work towards making life longer and more enjoyable. Thomas Edison didn't invent the very first light bulb, but his innovation and hard work led to the very first well-performing, commercially viable light bulb. He also continued to perfect it over time. Similarly, Merck didn't invent the first inhaler, but our team of engineers and scientists worked long and hard to take the state-of-the-art in dry powder inhaler technology to the next level so that patients can receive the maximum therapeutic benefit. Improving patient health is our mission at Merck, and we are very proud to receive this award.